because I cannot say this equation outside out loud enough times, I'm going to start off by saying for all these types of problems, we're going with the idea that the height at a specific time will always be equal to negative 16 t squared plus whatever that velocity is times time, the starting velocity, plus whatever the starting height is. So as I read the word problem, I'm looking for how fast was it going at first and where did it leave the ground from. So a golfer hits a golf ball off the ground with an initial velocity of 80 feet per second. So if that ball is being hit from off the ground, the initial height is 0. So this is just going to be 0. So I normally won't even write it, right? But the velocity, upward velocity, is 80 feet per second. So this is going to become an 80. So my quadratic is going to look like this. The height at any given time for this golf ball will be negative 16t squared plus 80t plus 0. But I'm not going to write plus 0 because adding 0 doesn't change anything. So we'll leave it just like that. Now we're trying to find the maximum height, which we know is the y value of the vertex. This guy is definitely standard form. So I'm going to go ahead and use the a, b, and c values. I'm going to use that formula opposite of b over 2a. And if you want to think about these t's in terms of x's, go ahead. But I'm going to continue to write t because t stands for time in seconds. So I'm going to say the t value for the vertex will be the opposite of b over 2 times a. If I double this value, it's negative 32. And again, it's going to be a gross number, so let me pause and get the old calculator out. I got a nice, friendly 2.5. So that means at 2.5 seconds later, this golf ball is as high as it's going to get. And then it's going to start to fall back down. So I just got to figure out what that height is, right? So this tells me when it's at its highest moment. But to find the highest moment, I'm going to figure out what is the height at that 2.5 seconds. So this notation is kind of strange, but I want to share it with you guys. Up here, when I was saying like the height at any given time t equals this stuff, now I know a specific time. So now I want to know the height at 2.5. So the second thing I'm just going to mention briefly is when you see this kind of notation in math, the way I want your brain to read it is this means height at any given time is this expression. This is saying the height at 2.5 is going to equal negative 16 times 2.5 squared plus 80 times 2.5. So the math teacher in me wants to tell you to say, plug it in. Just plug it into the function and get the answer. The human being in me wants to tell you how to read it, which is the height at 2.5 seconds is what I'm going to get if I plug in 2.5 for all t's. And again, I'll bust out my calculator here. Just plop this in a calculator, see what comes out. That'll be the height that is the highest. I'm going to pause while I get the calculator out. So assuming I didn't make any weird calculator mistakes, I ended up getting 100 feet as my final answer. And then to put everything, let me just put it all back in perspective. We have a golfer. Let me draw a little golfer. So we got this golfer. We've got this ball on the ground. He swings and whacks the ball up in the air. It goes up and it goes back down. Based off of this calculation, we knew that it was its highest point after 2.5 seconds had passed. And because we had this expression, we could take that 2.5, plug it into here, and figure out after that 2.5 seconds had passed, that ball was 100 feet in the air. So on the surface, we're really just finding the y value for the vertex, but in terms of like the real life application, that's what's happening. We'll do one last example, and I hope this is I hope it's sinking in, man. This is good stuff.